I'm going to show you how to solve some log equations in this video. So for the purpose of this video, I'm going to be using the method of keep the base and switch, or converting a log into an exponential function. So if I take a look at my first example, I have log base 5x minus 1 of 4 equals 1/3. In order to convert this into an exponential function, I'm going to keep my base, so 5x minus 1. Then I'm going to switch these other two pieces. So the 1/3 becomes the exponent and the 4 becomes the answer. These are equivalent expressions or equivalent equations because I converted. They mean the same thing. Now I just have to solve. So because I have a variable that's being raised to a power, in order to undo that power, we raise it to the reciprocal. And if I do it to the left side, I have to do it to the right side. So I'm left with just 5x minus 1 on the left, and then on the right, 4 to the third. We can use our calculators to evaluate, so 4 to the third is going to give us 64. And now we have to solve. So add 1 on both sides. 5x is equal to 65. Divide both sides by 5. And x is equal to 13. Now, with log equations, you always want to go back and check to make sure that you are not taking the base or what you're taking the log of and making either of them a 0 or a negative. It has to be positive. So my check is going to be to substitute in for x, 5x minus 1, I want to make sure this is not a negative or a 0. It ends up being 64. It's positive, so it's good. Checking to make sure nothing is negative or 0 when you substitute back in. Here's another equation. Log base 2 of x plus 1 equals 3. So keep my base. These other two pieces switch. So 2 to the third equals, jumping ahead here. 2 to the third equals x plus 1. 2 to the third in my calculator is 8. And then I'm going to subtract 1 on both sides. So x equals 7. To check, I just want to make sure that nothing is 0 or negative. So 7 plus 1 gives me 8. That checks out. Let's take a look at one more example. Log base x plus 1 of 27 is equal to 3. So keep my base, switch the other two pieces. So x plus 1 to the third power is equal to 27. Two ways to do this. I can either cube root both sides or raise it to the 1/3 power because they're equivalent. So if I cube root both sides, I get x plus 1 on the left, and on the right I get 3. Subtract 1 on both sides, x is equal to 2. Do my check, and I have x plus 1, so 2 plus 1 is equal to 3. That's a positive number, so we're good. So that's how you solve log equations using keep the base and switch. There are other videos posted if you want to take a look at some more difficult examples as well.